I'm Josh Bishop for OnlineComponents.com, and today we're going to learn more about Ohmite's PA and PV series of heatsinks. Ohmite is well known for their power resistors, but they also have a wide variety of other power-related products, including a line of board-level heatsinks. I have an example here of the PV series of heatsinks. This one in particular is a PV-T2X-38E. The only difference between the PV and PA series is that the PA series of heatsinks is anodized black, whereas this series is not. As you can see, these heatsinks are pin forged, so they have a large surface area, decreasing the overall thermal resistance, and we get convection cooling in multiple directions. Both the PA and PV series are designed to work with any device in a TO-220, 247, or 264 package. This example is a single clip, but there are dual clip versions available for either lower overall thermal resistance or to connect two devices to a single heatsink. This single clip is rated at 7.46 degrees Celsius per watt, but the family ranges from 8.07 to 3.13. If you're unfamiliar with thermal resistance, this equates to the temperature rise per unit power dissipated, so the lower the number, the better. It's interesting to note that the heatsink itself can also be attached directly to the PCB with these through-hole solder feet, giving it mechanical stability and another thermal conduit to dissipate heat if you'd like. I have a 50 ohm resistor in a TO-247 package that I'd like to use in a demonstration. On the back of the resistor is a metal piece that is electrically isolated yet thermally connected to the resistor itself. While attaching the heatsink to the resistor, you can see that it's extremely easy to open and close the cam clip, yet still get a tight hold. If I pull the clip out completely, it isn't tight enough to hold the resistor in place, but by pushing it back in so that it's a little snug when I flip the toggle, you get a strong mechanical connection. So you can easily and intuitively change the tension on the device being held. And one neat part of this is that this patented cam clip is actually used on most of Ohmite's heatsinks, not just the PA and PV series. While not absolutely necessary, to further improve the performance of these heatsinks, you'll want a thermal joint compound, and Ohmite has a couple of recommendations in their datasheets. So let me put on some thermal grease, connect this resistor to a power supply, and get the thermal imager ready so we can see this thing in action. Now that everything is set up and the resistor is starting to dissipate power, let's look at the thermal profile and how the heatsink is pulling the heat from the resistor. So it's been getting power, about 8 watts of power for a couple of minutes now, and I am looking at about 140, 145 degrees, somewhere in that general area for the warmest portion of the resistor. As you come out here, you can see that the heatsink is also coming up in the temperature, and you can see how right where it's connected is the warmest, yet it's moving out across the whole structure so that it's increasing the surface area. So let's give this a couple more minutes, maybe another 10 minutes to let it come up to equilibrium so we can see how the temperature goes across. And right now it's dissipating in even and regular 8 watts, and we'll see what happens. So it's been a little bit over 10 minutes, and it has reached basically equilibrium right now, and you can see that the hottest spots are in the mid 140s, about 145, and as you look throughout the heatsink, it drops down and it gets down to about the mid 120s, but most of it is about 135 to 145 degrees Fahrenheit. So this shows how it's taking the heat from the resistor and goes out into that one little specific place that the resistor is touching it and spreading it out not only among the plate in the back, but also out on the pins. And with all that surface area of the pins, I've noticed that if I breathe on it, like blow very gently on it, it causes the temperature to drop significantly, to wait for a little while and then slowly get back warmer. So while this works very well convection cooled, you can get even more performance out of it by using forced air cooling. And that's it. The PA and PV series of Ohmite heatsinks are easy to use, yet highly effective. To learn more about these heatsinks and other Ohmite products, go to OnlineComponents.com.